According to most astrophysicists, all the matter found in the universe today, including the matter in people, plants, animals, the Earth, stars, and galaxies, was created at the very first moment of time, thought to be about 13.8 billion years ago. The universe began, scientists believe, with every speck of its energy jammed into a very tiny point. This extremely dense point exploded with unimaginable force, creating matter and propelling it outward to make the billions of galaxies of our vast universe. Astrophysicists dubbed this titanic explosion the Big Bang. To understand the origins of the universe, you have to go backward in time to a point where time equals zero, that is, t equals zero, or precisely when time began. The most widely peer-reviewed and accepted theory on the origins of the universe is the Big Bang theory. It may seem difficult to imagine a time, about 13.77 billion years ago, when the entire universe existed as an infinitesimal singularity. However, the Big Bang theory basically says the universe, as we know it, started with an infinitely hot, infinitely dense, compact, singularity existing in a form smaller than a subatomic particle. Smaller than these particle images. The singularity contained all the matter in the cosmos, all of space itself. So everything we know of the beginning, was a point of infinite denseness and infinite heat. A few millionths of a second later, quarks aggregated to produce protons and neutrons, combining within 3 minutes to produce the nuclei of light elements. As the universe continued to expand and cool, things began to happen more slowly. It has long been theorized that hydrogen, helium, and lithium were the only chemical elements in existence during the Big Bang, when the universe formed, and that supernova explosions, stars exploding at the end of their lifetime, are responsible for transmuting these elements into heavier ones and distributing them throughout our universe. The Big Bang was the instantaneous creation of all of space and time, containing energy to drive the expansion, and enough matter for over 100 billion galaxies. There was so much energy in the universe during those first few moments that matter as we know it couldn't form. As the universe expanded, matter began to form and radiation began to lose energy. In only a few seconds, the universe formed out of this singularity that stretched across space. It took 380,000 years for electrons to be trapped in orbits around nuclei, forming the first atoms. 100 million years later, the first stars began to grow in hydrogen clouds. So what does this mean? This singularity containing all the matter in the cosmos, all of space itself. The initial singularity of seemingly infinite density is thought to have contained all of the mass and spacetime of the universe, before quantum fluctuations caused it to rapidly expand in the Big Bang, and subsequent inflation, creating the present-day universe. The initial state can only be described by a theory that unites gravity and the quantum world. At present, we do not have such a theory. This period known as cosmic inflation will be discussed in a future video. Extrapolation of the expansion of the universe backwards in time using general relativity produces boundless, or infinite density and temperature at a bounded, or finite time in the past. A side note. General relativity, in its simplest description, is a theory of gravitation developed by Albert Einstein between 1907 and 1915. It says that the observed gravitational effect between masses results from their warping of spacetime. So, this quantum singularity indicates that general relativity is not a sufficient description of the laws of physics at this time scale. In other words, models based solely on general relativity cannot extrapolate toward the singularity beyond the end of the Planck epoch. The Planck epoch is the earliest period of time in the history of the universe. In Big Bang cosmology, the Planck epoch, or Planck era, is the earliest stage of the Big Bang, before the time passed was equal to the Planck time, Tp, or approximately 10 to the minus 43 seconds. It should be noted that some sources have 10 to minus 44 seconds and others have 10 to minus 41 seconds. Planck time is the time it would take a photon traveling at the speed of light to cross a distance equal to the Planck length. This is the quantum of time, the smallest measurement of time that has any meaning, and is equal to 10 to the minus 43 seconds. Within the framework of the laws of physics as we understand them today, no smaller division of time has any meaning, therefore, We can say only that the universe came into existence when it already had an age of 10 to the minus 43 seconds. A side note. It is generally assumed that quantum effects of gravity dominate physical interactions at this time scale. In response to the inaccuracy of considering only general relativity, as in the traditional model of the Big Bang, alternative theoretical formulations for the beginning of the universe have been proposed, including a string theory-based model in which two brains, enormous membranes much larger than the universe, collided, creating mass and energy. Although there is no direct evidence for a singularity of infinite density, the cosmic microwave background is evidence that the universe expanded from a very hot, dense state. More detail on the cosmic microwave background in a later video. The Big Bang theory is firmly established and backed up by 3 lines of evidence. From speeding galaxies to ancient gas clouds, there is a lot of evidence that we can detect today. There are remnants of the Big Bang that tell a clear story about the origins of our universe. The first is that the universe is expanding. Galaxies are flying apart, so in the past everything was closer together and must once have been in one spot. The second is the discovery of the cosmic microwave background radiation, CMB, the afterglow of the hot young universe. WMAP launched on June 30, 2001, with the goal of sensing subtle temperature differences in the cosmic microwave background, that is, the glow of the first atoms to release their radiation 380,000 years after the Big Bang. Since then, it has provided the most accurate measurement of the age of the universe, proved the existence of dark energy, showed that just 4% of the universe is made of ordinary matter, and supported the idea that the universe inflated from subatomic scale to the size of a soccer ball in its first trillionth of a second. A 2013 map of the background radiation left over from the Big Bang, taken by the ESA's Planck spacecraft, captured the oldest light in the universe. Planck's observations mapped the background in unprecedented detail and revealed that the universe was older than previously thought, 13.82 billion years old, rather than 13.7 billion years old. The Research Observatory's mission is ongoing and new maps of the CMB are released periodically. And the third remnant of the Big Bang that demonstrates the origins of the universe. The abundance of light elements, deuterium, helium and lithium, in stars and gas clouds are as expected if they formed by the nuclear process in the Big Bang fireball. The evidence points to the Big Bang occurring about 13.8 billion years ago. The universe then swelled rapidly for a fraction of a second, a period known as cosmic inflation, and expanded steadily, cooling as it did so. So, we are left with the question, who or what cracked the cosmic rat? Or, who or what did the cosmic fart? In other words, how did the singularity come to be? One of the common misconceptions about the Big Bang model is that it fully explains the origin of the universe. The Big Bang is an attempt to explain how the universe developed from a very tiny, dense state into what it is today. It doesn't attempt to explain what initiated the creation of the universe, or what came before the Big Bang, or even what lies outside the universe. However, the Big Bang model does not describe how energy, time, and space were caused, but rather it describes the emergence of the present universe from an ultra-dense and high-temperature initial state. While it is not known what could have preceded the hot dense state of the early universe or how and why it originated, there is much speculation on the subject of cosmogony. Some speculative proposals in this regard, each of which entails untested hypotheses, include 1. The Big Bang was caused by quantum fluctuations. The Big Bang can be thought of as a quantum event, originating from very chaotic space-time in which the other quantum fluctuations might have led to other parallel universes. That scenario had very little chance of happening, but, according to the totalitarian principle, even the most improbable event will eventually happen. It took place instantly, due to the absence of perceived time before the Big Bang. 2. Models in which the whole of spacetime is finite. For these cases, the Big Bang does represent the limit of time but without a singularity. In such a case, the universe is self-sufficient. 3. Brane cosmology models, in which inflation is due to the movement of branes in string theory. The pre-Big Bang model, the ekpyrotic model, in which the Big Bang is the result of a collision between branes, and the cyclic model, a variant of the ekpyrotic model in which collisions occur periodically. In the latter model, the Big Bang was preceded by a big crunch and the universe cycles from one process to the other. 4. Eternal inflation, in which universal inflation ends locally here and there in a random fashion, each endpoint leading to a bubble universe, expanding from its own Big Bang. Proposals in the last two categories see the Big Bang as an event in either a much larger and older universe, or in a multiverse. And 5. Religious and philosophical interpretations. As a description of the origin of the universe, the Big Bang has significant bearing on religion and philosophy. Some believe the Big Bang implies a creator. So what did Buddy of Town learn about the quantum singularity and its burst? There was a lot of compaction, pressure and heat build up in that quantum singularity containing everything needed to ultimately create the universe we see today. It took place a long time ago. More than 18 billion years. We are unable to go back to time equals zero, but we are pretty close. We are unable to determine how the singularity came to be, but there are lots of theories. You can still align with a religion and follow science. It does not have to be one or the other. And, you can understand without knowing all of the complex calculations. In our next video, we will discuss the stages of the Big Bang, and evidence of the Big Bang. If you would like to follow along to see Buddy from Town become Buddy of Singularity, please click subscribe and a like would be appreciated. Until next time, dear viewers, keep looking up and looking back, way back.